So, we got this far with that identity, but um, so I really haven't been able to um, do a whole lot more with it. Now, if we take the z to the fifth minus 1, and by not being able to do a whole lot more with it, um, I'm kind of stuck using what they give me. And so not so much showing, at least in my mind, the way one would show that this is true. Um, so they have pi over 5 like that, plus 1, and then times the z squared minus 2z cosine of 2 pi over 5 plus 1. Now, so the real key is showing that these last two factors above here, above this line, that they multiply together to be z to the fourth plus z cubed plus z squared plus z plus 1. And it's interesting. I can do, if you just start multiplying those two things together, what it turns out is you end up at a place where if this is true, then you can take care of the z cubed in the z in the z term. So it's kind of obvious looking at these that the z to the fourth term is fine and the 1 term is fine when I multiply them together. When I multiply these two things above the line there together, I'll get a z to the fourth and I'll get a 1. But then after that, the z cubed, the z squared, and the z terms all have these cosines in them. But if this is true, the z cubed and the z take care of itself. But the z squared term, still has something else, and we'll kind of see what that is here when I do this. So what I'm going to do is I'm going to let z equal -1, and so when you do that, you'll get a -2 is equal to -2 times 1 minus 2. And I'm going to write, instead of cosine of pi over 5, I'm going to write C1, just to make it a little simpler. And then I'll get a 1 and a plus 2, and I'll call this one C2 with the cosine 2 pi over 5, and then plus 1. And so now I could divide both sides by this -2, and I'll put this stuff on the left-hand side. And so I have 2 minus 2c1 times 2 plus 2c2 is equal to 1. So now if I divide through by 4, so divide that by 2, divide that by 2, divide that by 4, you see. So I'll have 1 minus C1 times 1 plus C2 is equal to 1/4. And so this says what? That 1 minus C1 plus C2 minus C1, C2 is equal to 1/4. And now this part right here, so I can subtract 1, and so I'll write C2 minus C1 minus C1 C2 is equal to negative 3/4. And now, though, this part here is actually what I did back here. So see, there's the C2 minus the C1, so I know that that's negative 1/2. So this is negative 1/2 minus C1, C2 is equal to negative 3/4. Well, so I add a half to both sides, and I get negative C1, C2 is equal to negative 1/4, or C1, C2 is equal to 1/4. And it turns out that that's exactly what you need. So again, if you come back here and you multiply out that thing, the condition here takes care of the z cubed and the z terms, but the z squared term, well, it turns out what you need is for C1, C2 to be a fourth. Well, the problem with saying that I have that condition here is, well, I used this identity here to end up with C1, C2 as a fourth, and that's the best I've been able to do, though. Now the thing is, the bottom line after that is they say, well, once you come up with the identity they give you in 118, come up with formulas for the two cosines there, the C1 and the C2. Well, this is enough. So if I write C2, which is the cosine of 2 pi over 5, is equal to 1 over 4 cosine pi over 5. So if I know that, and then I substitute that back here, right? So I'll have that 1 over 4 cosine of pi over 5 minus cosine pi over 5 was equal to negative 1/2, I think, right? Yeah, okay. So now it's a matter of solving a quadratic equation, because if I multiply through by 4 cosine pi over 5, I get 1 minus 4 cosine squared pi over 5 equals, let's see, so 4, so that'd be minus 2 cosine pi over 5. So it's just a quadratic equation in that cosine, and I know cosine pi over 5 has to be the positive root and so forth, and so if I solve that, I'm not going to go through all that, but you do get cosine of pi over 5 is equal to 1 plus the square root of 5, all divided by 4 when you solve that. And it's interesting, the negative root then actually turns out to be, if you then plug this in to the any of these equations, like the C1, this one C1, C2 equals 1/4, or you get that the cosine of 2 pi over 5 is the 1 minus the square root of 5 over 4, so the negative root of that quadratic equation. And that's what they want you to get. So I kind of had to punt on this one. I'm just not seeing where they are kind of getting some of this. Again, I can go with the factoring and do some nifty work here, with real parts and so forth, and I can get the first part of this, or part of what you need. But I haven't been able to get this product part, other than basically using the answer and plugging in. So I just I haven't gotten that one, and so I'm sure we could look it up and see, but I haven't done that. Uh, but at any rate, if you go ahead and use that identity, certainly yes, you can get your expressions for cosine of pi over 5 and cosine of 2 pi over 5. So that's where we'll leave 118 at this point.